Let's solve the following system of linear equations. We have the following equations: 8x equals 12 and minus 8x plus 5y equals a negative 2. So this is our system of linear equations, and the first thing we want to do, now that we know we can solve by elimination, is we want to see if one of the variables in both equations have the same coefficient that are opposites of each other. And indeed we do. We have a positive 8x here and a negative 8x in this one. So by now we know that if we add these two equations together, these two variables will cancel and we'll have one equation with one variable in it, so we can have that value for that one variable. And we can plug back into either equation and get the other value for the other variable. So let's go ahead and do that. We have minus 8x plus 5y. It doesn't matter which equation is 1 and which one is equation 2. As long as we're adding them together, it doesn't matter, right? And we're going to add this equation to this equation. So we have a positive 8x. And we can, right here, we can put a 0y as a placeholder just to help us line things up a bit, if you'd like. So we're adding these two equations together. So a minus 8 and a positive 8 will cancel, getting rid of this variable. 5 plus 0 is 5. We have 5y equals negative 2, and a positive 12 will give us a positive 10. And we can solve for y by dividing both sides by 5, which will give us y equals 2. Okay, so at the beginning we noticed that both of our equations had a variable x, which the coefficients were opposites of each other. We had a positive 8 and a negative 8. We should recognize that if we add these two equations, just like so, just like we did in elementary school, we can cancel these two variables and just add down in the columns. All right, so make sure they line up as well. We always want to remember that. Now we can substitute in 2 into either equation and for y. If you noticed, equation 1 doesn't have a variable y. We have a 0y, technically. So if you plug in 2 for y, well, this is just 0, so we'd have 8x equals 12, which is actually what the original equation is. So we can actually get our variable, a value for our variable x, by simply dividing straight up here by 8. But just for a little bit more practice, and to show you that it does work in both equations, let's go ahead and use the second equation. So we have minus 8x plus 5 times y, which is 2, equals minus 2. Let's go ahead and solve this for x. So we have minus 8x plus 5 times 2 is 10, equals minus 2. We can go ahead and subtract 10 from both sides, moving everything to the right except the variable. So we have minus 8x equals minus 2, and minus 10 is minus 12. Let's go ahead and divide both sides by negative 8 so we can solve for a positive x. That'll give us x equals, if we cancel these two negatives and simplify 12 over 8, we get 3 over 2. Factor a 4 out of the top and the bottom. And we have our two values for our solution. So let's go ahead and state it. The solution to this system of equations is 3 halves and 2. This is the point where these two lines intersect. And we can actually, it's a good practice to check this by plugging in the value for x and y into both equations, and it'll actually hold true. All right, so let's go ahead and look at some more of these. I want to get plenty of practice, because this is actually a really good way to solve systems of linear equations. So our next system is we have minus 2x minus 2y equals 2, and 6x plus 2y equals minus 4. All right, so this is our system of linear equations, and the first thing we want to do is we want to see if either variable in both equations has a coefficient that are opposites of each other. And here we indeed have that case. We have a minus 2y and a plus 2y. So we know that if we add these two equations, these two terms will cancel, which means we can simply have one equation solve for x. So let's go ahead and do that. We have equation 1, minus 2x minus 2y equals 2. And the second equation we can add to it. We have 6x plus 2y equals minus 4. These two terms will cancel when we add them together. We have minus 2 plus 6 is a 4x. And once again, we can put 0y here for a placeholder just so we make sure everything lines up. We have a -2. So let's go ahead and divide both sides by 4 to solve for x. These two terms will cancel. That cancels as well. So we have x equals -2/4 is a -1/2. And we have a value for our first variable. All right, let's go ahead and find the second one. We can plug it into either equation. Let's go ahead and use this one because it has less negatives. So we have 6 times x, which is a -1/2, plus 2y, y is the variable we want to solve for, equals -4. Let's go ahead and solve this. We can factor this out and simplify a little bit. This becomes 1 and 3, so we have 3 times a -1 is a -3, plus 2y equals -4. We can add 3 to both sides. Those two terms will cancel, so we have 2y equals -4, and plus 3 is -1. And we can finish it off by dividing both sides by 2, which gives us y equals a -1/2. If you notice, the solution to our equation is going to be -1/2 and -1/2. We can actually check this by plugging them into x and y, respectively, into both equations, and they'll even out. So let's go ahead and look at one more while we have time. We have y equals 3, and 3x minus y equals 9. All right, so let's go ahead and solve this system of equations. We should notice that we have two variables. If we add them together, they'll cancel out. We have a positive y and a negative y. So let's go ahead and add these two equations using our elimination method, so we can have one equation with one variable in it. So let's go ahead and write this first one. We have 3x minus y equals 9. And to that, we're going to add this equation. We have y equals 3. We're going to drop the placeholders now. We should be able to line them up pretty well by now. So when we add these, we have a minus y and a plus y, which will cancel. So we just have 3x equals 9 plus 3 is 12. And we can divide both sides by 3, which gives us x equals 4. 12 divided by 3 is 4. So we have a value for one of our variables. Let's go ahead and plug it in. But if you notice, we're given the value of one of our variables already. So we can substitute directly into our second equation to find the other value for the other variable. Or we can actually just say, hey, well, we have x and we already know what y is, so we don't even need to do that. So we can just go ahead and state the solution. We have 4 and 3. And that's actually the solution, the point where these two lines intersect. If you notice, this is going to be a horizontal line whenever we have y equals, and it's going to be at the point y equals 3. So a good check is to plug this x into the other equation to make sure you get 3 in this equation for y. So we'll do some more of these in the next video. We'll actually be looking at an application of solving systems of linear equations by elimination whenever we can add two equations together. So I'll see you in the next video.